Okay, everyone, so section 1.1, graphing quadratic functions in standard form. Okay, we're talking algebra 2 here. All right, so this first page is just some basics on graphing parabolas in standard form. Okay, definition number 1, guys, you see there, a quadratic function. I'm just going to change my pen setting because it's a little bit too thick. So we're going to go marker here. So first things first, a quadratic function, okay, is a function that can be written in standard form. Y equals ax squared plus bx plus c, where a is not equal to 0. Let me just explain that real quick, guys. You got y is equal to ax squared plus bx plus c, okay? So change my pen settings one more time. Medium, let's go medium point, see if that works for us, okay? A, B, and C, guys, those are going to be your coefficients of our quadratic function. Okay, so they are going to represent coefficients, guys. We mean numbers. Okay, anytime something is quadratic, that means that the biggest exponent is a 2. Okay, I know that's kind of odd because typically when you think quad, you think 4. But when we're talking quadratic functions, the biggest exponent is 2. The graph of a quadratic function is going to be something we call a parabola. That is a U shape. Okay, all right, a U shape. If it's upside down, it's going to look like an N. Okay, a parabola is a U-shaped figure. Okay, so getting there to where it says key concept, I'm going to be working in here right now. All right, the first thing it says underneath there is the parent function for quadratic equations. What it means by parent function is all parabolas are going to work kind of off a base graph. And that base graph, that parent function, is f of x is equal to x squared, okay? Or y is equal to x squared. That's the parent function, okay? Now, if I was to make a quick table for this graph of y is equal to x squared, and I'll do it up top here, I'll create myself a little more space. Okay, if I was to make a table, I have y, I'm some trouble here at my marker. I got y is equal to x squared. So I'm going to make an xy chart here. Okay, and I'm going to put 0 in the middle, and you're going to find out why in a minute. Okay, when x is equal to 0, that means you would do y is equal to 0 squared. 0 to the second power is 0 times 0, which is 0. So 0 comma 0 is my first order pair, which is obviously the origin, which is right there. If I plugged in the number 1, that would mean I would have y is equal to 1 squared. 1 squared is 1 times 1. So y is equal to 1. So the order, the y coordinate with the x coordinate of 1 is 1. If I went to 2, I would have y is equal to 2 squared. So that would be 2 times 2, which would be 4. So my y coordinate there is 4. So I got 1 comma 1, and I got 2 comma 4. Okay. Now, the beauty of parabolas is that they are symmetric. Okay. What it means by symmetric is that it's able to be flipped on to the other side of itself over what we call the axis of symmetry. Okay, which is defined here. The axis of symmetry is what divides the parabola into mirror images and is going to pass through what we call the vertex. Okay, the vertex is where the parabola changes places. Okay, that is defined right here. That is the lowest or highest point of the parabola, depending on what happens with our equation. Okay, the vertex of our parent function, all right, this f of x equals x squared or y equals x squared, that is 0 comma 0. So this is our vertex right here. That's where the graph is going to change direction. Now, if I started to draw the first half of my parabola, you can tell it's going like that. Now, the axis of symmetry is going to go through the vertex. So my axis of symmetry here is going to travel right through the vertex, right down there. So that is what's dividing or cutting this parabola into two separate pieces. Now, what that means, guys, is that this point over here is going to have a mirror image on the other side. So if this point is 1 unit away from the vertex, that means I got another point 1 unit away from the vertex this way. That would be the point -1, 1. So I can go the other way, -1, 1. This point up here is 1, 2 units away from the vertex. So I'm going to have a mirror image over here, which would be that point right there. That's the point -2, 4. Okay, so the second half of my parabola is going to travel something like that. Okay, if I was to expand this thing and I was to go to 3 to the second power, that's going to go through 3, 9, right? So I got 1, 1, I got 2, 4, and now I have 3, 9, which means on the other side, I have -1, 1, I have -2, 4, and I have -3, 9. Okay, so that's what we mean when we talk about our parent function, y equals x squared, which is this graph. Okay, this graph right here, they have it a little bit neater for you over there. That is our parent function, okay, for quadratic equations. That's what everything works off of. Okay, now if I go down to my first example here, we're going to graph y is equal to 2x squared, and we're going to compare the graph with the graph of y equals x squared. First off, guys, I want to give you a little hint. Okay, quadratic equations are supposed to look like this. We just talked about this: ax squared plus bx plus c. Okay, a is always attached to the x squared. B is always attached to the x, and c is the constant. C is always going to be by itself. Now, if you notice in this function, in this equation, we got y is equal to 2x squared. Okay, if we were identifying our coefficients, this equation is only going to have an a. Okay, a for this one is equal to 2 because that is the number that's attached to the x squared. There is no b because there is no x term. There is no c because there is no constant. Now, the little hint is when there is no b term, okay, no b term, the vertex will be at 0, whatever c is. If there is no b term, the vertex is going to be at 0, whatever c is. That's the vertex. So this one does not have a b term. It also doesn't have a c term. So the vertex here is going to be 0, since there's no c term, 0, 0. So here's my vertex, 0, 0, right there, the origin. Now, I don't know what the graph is going to do from here because this one's a little bit different from the parent function. So I'm going to make a table, but I can use that vertex to help me out. If I start making a table, I'm going to find 5 ordered pairs. One of them I already know. Okay, I'm going to put the vertex, my 0, 0, I'm going to put that in the middle because that's where I know the graph is going to change direction. And I'm going to go 1 over here, 2 over here, and I'm going to go -1 on this side, -2 on this side. Now, you're not going to need to find all of the missing spots there, the 4 missing numbers. You're only going to have to find 2 because remember, the axis of symmetry is going to go through this vertex, which means it's going to create mirror images. Okay, so when I start finding the other numbers, let's say I want to plug in x is equal to 1. Okay. So when x is equal to 1, I have y is equal to 2 times 1 squared, which is 2 times 1 to the second power is 1. That's 2. So I got the point 1, 2 on the graph. If 1, 2 is on the graph, that means -1, 2 is also on the graph because these 2 points have to mirror each other. -1, +2. So you're finding 1, but it's really giving you 2. So the first part of my parabola goes like this, okay? Now I'm going to plug in x is equal to 2. When x is equal to 2, y is equal to 2 times 2 squared, which is 2 times 4, which is 8. So 2 comma 8 is on the graph. 1, 2, and then up 8. So I'm going to go all the way up to 8, which is right. Let's see, 3, 4, 5, 6, 7, 8. Okay. This point is going to mirror image over here. This is 2 away from my axis. This is 2 away from my axis. So you see the parabola is going to keep on going that way. Finish my graph. 2 comma 8. So I'm also going to have negative 2 comma 8. Okay. Hopefully this is all making sense. Okay. Now, how does this graph compare to the parent function? Okay. The parent function looked like this. Okay. It had a vertex of 0 comma 0. Then we went 1 comma 1, negative 1 comma 1. Then we went 2 comma 4, negative 2 comma 4. Okay. Actually, let me put that point in the wrong spot. That point should be here. So the parent function actually looks something like this. Okay. So for lack of a better word, guys, what would you say about the parent function? Or what would you say about our new graph? Okay. I think the obvious choice is it's a little bit skinnier, right? It's a little bit slimmer than our parent function. Okay, and we're going to talk about what that means in a minute. Okay, let's try another one. Graph a function of the form y equals ax squared plus c. Okay, so we got a similar problem here. Okay, if we were to label our coefficients, right, I have a is equal to negative 1/2. There is no b term because there is no x term, so that's c. Okay, and c is the constant, the number that's by itself, that's going to be a 3. Okay, so my vertex here, your vertex is going to be 0, comma, whatever c is. In this case, c is equal to 3. So my vertex for this one is 0, comma, 1, 2. There's my vertex, 0, comma, 3. So when I make my table, I'm going to put 0, comma, 3 in the middle, since I know that's where the graph is changing direction. So here's 0, comma, 3. Now, what I'm going to do when I find my other ordered pairs, when I find this one, when I find my x here and my x here, I'm not going to go 1 and 2. I'm actually going to go 2 and 4, which means on the other side, I'm going negative 2 and negative 4. And the reasoning behind that, guys, is because of this negative 1/2 in the problem. When you have a 1/2 in the problem, that means you're going to have to divide it by 2. If you're going to have to divide it by 2, wouldn't it make sense to use nice, neat, even numbers? So that's why I picked 2, 4, and negative 2, negative 4, instead of picking numbers like 1, 2, 3, 4, 5. Then I'm going to mix in odd numbers, which is going to give me decimals. Okay, so I have my vertex already drawn, which means my axis of symmetry is going to go right through it. That's going to be my axis of symmetry. Okay, now let's start finding my missing ordered pairs. So when x is equal to 2, okay, I'm going to plug in 2 first. That means y is equal to negative 1/2 of 2 squared plus 3. So negative 1/2, 2 squared is 4 plus 3. Negative 1/2 times 4 would be negative 2 plus 3. Negative 2 plus 3 is positive 1. So 2 comma 1 is on the graph. Okay, 1, 2 to the right, 1 up. There's 2 comma 1. That point is 2 units away, so it's got a mirror image over here, which would be this point. That's the point negative 2 comma 1. So negative 2 comma 1. Now you see what's happening here. This graph is going to start to go down. Okay, now let's plug in 4. When x is equal to 4, y is equal to negative 1/2 of 4 squared plus 3. So negative 1/2, 4 squared is 16 plus 3. Negative 1/2 of 16, that's going to give me a negative 8 plus 3. That's a negative 5. So 4 comma negative 5, which means also negative 4 comma negative 4 comma negative 5 is on my graph. 1, 2, 3, 4, 5. And then negative 4, 1, 2, 3, 4, 5 is also on my graph. Okay, and you see the parabola is going to continue going down this way. Okay, now again, the parent function looks something like this. This is the parent function. Okay, there's your y is equal to x squared parent function. So we got a lot going on here, guys. First of all, the obvious thing you're going to notice is that the graph is flipped over, right? It goes down. That should be obvious. You should also notice that my blue graph, right, the one I just worked on, not only is it flipped over, but it's also a little fatter. It's a little wider, okay? The A value, guys, is what makes that happen. All right, the A value in your equation is what makes it skinnier or wider, or it makes it flip over or stay opening up. But these parabolas are either going to open up or down, okay? They could be skinny, they could be wide, and it all depends on what A is. So if I take a look at this next screen here, guys, well, actually, this next screen just gives you some equations. You can practice these on your own if you want to make tables and take a look at what happens to the graphs. These are some problems for you to try on your own, okay? But if I go down here, there's some hints written here, okay? So properties of the graph, y equals ax squared plus bx plus c. So I'm looking right here, okay? And then they give you a list of some things to look for, okay? First of all, okay, look at your a value. If the a is a positive number, I'm looking right here, guys. Change my color here, okay? If that a value is a number that's bigger than 0, which means it's positive, that's going to make our graph open up. If that a is a negative number, that means our graph is going to open down, okay? The next thing I want to talk about is right here, okay? The bigger the a value, I'm going to simplify this one for you. The bigger the a value, the skinnier the graph. The smaller the a value, the wider the graph. So as a gets bigger, a 1, a 2, a 3, a 4, a 5, it's going to get wider and wider and wider. As a gets smaller, like 1/2, 1/3, 1/4, 1/5, it's going to get wider and wider and wider. Okay, the next bullet there, your axis of symmetry, and we're going to practice this in the last example, is located at x is equal to negative b over 2a. And you're going to see how we execute that when we go over our last problem. Okay, same thing with the y-intercept. The y-intercept, okay, my y-intercept is c. All right, so my y-intercept is always going to be 0, comma c. You're going to see these steps in the next problem we take a look at. Okay, so if I look at my parent function, one last time here, my parent function looks something like this. Okay, the bigger the a value, the skinnier it's going to get. The wider the a value, the wider it's, or the bigger the a value, I'm sorry, the smaller the a value, the wider it's going to get. And then if a is negative, that's just going to make my graph flip over. Okay, but you're going to see now the vertex is not necessarily going to be at 0, comma 0. That's going to change. Let's take a look at this last example. Okay, this last example, I'm going to walk you through our steps to graphing any function that I can throw at you. So we got y is equal to negative 2x squared, 2x squared minus 8x plus 6. So first things first, let's identify the coefficients. Okay, a is the number that's attached to the x squared, that's 2. B is the number that is attached to the x. For the first time we're seeing a b here, that's negative 8. And c is the number that's by itself, that's going to be equal to 6. We're going to see how that plays in a minute. The first thing I want you to take a look at is the fact that a is equal to 2. Because a is a positive number, that means our parabola is going to open up. Okay? Because a is also a number that's bigger than 1, it's a little bit bigger than 1, that means it's going to be a little bit wider than our parent function. I'm sorry, a little bit skinnier than our parent function. The bigger the A, the skinnier the graph. Okay, step number 2 is we're going to find the vertex. To calculate the x-coordinate of the vertex, the x-coordinate is equal to the opposite of b. Oh, actually, I wrote a 6. The opposite of b over 2a. Okay, so because b is -8, the opposite of b would be +8 over 2a. 2 times a, which is 2. So that is 8 divided by 4, which is 2. So the x-coordinate of my vertex is 2. So how do I find my y-coordinate? Okay, what you're going to do is you're going to plug it in to this equation. So it's going to be 2 times 2 squared minus 8 times 2 plus 6. 2 times 2 squared, 2 to the second power is 4, minus 8 times 2 is 16, plus 6. 2 times 4 is 8, minus 16 plus 6. 8 minus 16 is -8, plus 6 is -2. Okay, you can use your calculator, obviously, to do all that. So that means, guys, that my vertex is 2, -2. 2, -2, 1, 2. So there's my vertex, which means my axis of symmetry is going to be right here. Okay, that's my axis of symmetry. I already know my graph opens up, so my graph is going to look something like that. Okay, we're going to find more ordered pairs in a minute. Okay, so that's step number 2. Step number 3 is draw the axis of symmetry. I already did that. Okay, that's my red line passing right through that vertex. Step number 4 is identify the y-intercept. The y-intercept of any graph is where the graph crosses the y-axis. Okay, so it's 0, the y-intercept is going to land on the y-axis. So this is where your y-intercept is going to be. It's going to be somewhere on that axis right there. It's always going to be 0, comma, whatever c is. In our case, c is 6. So our y-intercept is 0, comma 6. 0, comma 1, 2, 3, 4, 5, and 6. Now that's big for us because now if I have this point, which is 2 units away from my axis of symmetry, that means I have another one over here. I have a mirror image. So not only is 0, comma 6 on the graph, right? This point, which is 2 to the right, would be 4, comma 6 because it's 1, 2 to the right of the axis of symmetry and also the vertex. So this point is 4, comma 6. Okay, so you can kind of get a feel for what's happening with your parabola here. The last thing you're going to do to evaluate the function is find one more point, which is actually going to give you 2. So they asked you to use x is equal to 1. You can use anything you want. Okay, you can use x is equal to 3, x is equal to 5. Let's use x is equal to 1 since that's a pretty simple number. So when x is equal to 1, you're going to plug that number in. 2 times 1 to the second power minus 8 times 1 plus 6 at the end. 2 times 1 squared, 1 times 1, that's 1, minus 8 times 1, which is 8, plus 6. So I got 2 times 1 is 2, minus 8 plus 6. 2 minus 8 is -6, plus 6 is equal to 0. So that means the point 1, comma 0 is on your graph, right? Your x-coordinate is 1. You plugged it in. Your y value is 0. So my point is 1, comma 0. So 1, comma 0, 1 to the right and stop. So the left-hand side of my parabola looks something like that, okay? If this point is 1 away, right? You see that little space in between the graph and the axis of symmetry? That means I got another one over here. So that point is 1 away. So I got 1, comma 0 over there. Over here, I have 3, comma 0. And you can see what the second half of the graph looks like. And that's step number 6, right? Your last step is to draw the parabola through the plotted points. Okay. So obviously, guys, rewatch this if you have to. I know I threw a lot out at you at one time, but you do have the ability to go back and watch things again. The only other thing I want to talk about, guys, this is the last little slide here. minimum and maximum values, okay? When the graph opens up like it does here, your vertex is a minimum, all right, because it's the bottom. When your graph opens down like it does there, your vertex is a maximum because that's the highest possible point in the graph. So when we talk about minimums and maximums, that's what I'm talking about. Okay, guys, good luck and ask questions if you need to.